Assalamu alaikum, I am Aldana. In my video I'm going to describe how to do CFD and the SolidWorks. I choose a cross-flow turbine, which is water turbine. So I am going to do flow simulation and this cross-flow turbine step by step. Before I start the simulation, I will show you the assembly parts. First we need to go to the configuration manager. And now we will double click in the XPL view. Here you can see the parts of my assembly. Now I will return back to the assembly by double click in the XPL view. So now let's start the simulation. First I will go in the feature manager. Then we will go to the option. I will add ends. Then we will go a little bit down until we can see the SolidWorks flow simulation. I will click on it and choose it. Then I will press OK. We will wait for the flow simulation until it's become in this table. So now you can see it's download the flow simulation here. So we will double click in the flow simulation and we will delete the old simulation before we start. So now as we can see this table, first we will go into wizard. And now I will name my project into project for fluid. Then I will click next. In this system we are going to use the SI, which is international unit, and I will press next. The type of analysis I will choose is external, so it will external. From the physical features we are going to choose the gravity and the rotation. From the fluids, we have many types of fluids, but I will choose liquid. I will go a little down to choose water. When I choose the water, I should to choose the gravitation to see it in the flow simulation. Then next, and now next. So as we know, the parameter is here, as shown that my assembly is gonna to move in the y-axis, so I need to change the y direction into -100. Now I will finish the wizard. Here you can see the domain of the flow, where it's moved, the area of the flow. So now we need to increase this area. First we are going to go to the computational domain. We'll press right click and we will add on the edit. We have two types to increase or decrease this area. First type is from this arrow, and the second type is to type the number for the x, x, or y, y, or z, minus z. The first number is going to be 0.271611785 meter. The second one is going to be 0.068027513. The next one is going to be in the y. It will be 0.600467165. The other side for y is going to be only 0, and the z is also going to be only 0. And now in the z we will go with negative direction, which is negative 0.379374487. So now the area of the fluid is changed into smaller, as you can see. So now I will go and press OK. The next option is going to be in the rotating region. So we will right click and insert rotating region. The rotating region is going to be in this shaft. So I will click on the shaft to choose this shaft. As you can see, it is in the opposite direction. So what we are going to do is to change the parameter for the angular velocity. So it will be negative 300. So as you can see now, it becomes in the right direction. Now we will press OK. The next step is going to be in the goal. We will right click, insert global goals. As we mentioned before, we will choose the velocity in the y direction. So we will choose this, 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 this. After we check the options of the velocity in the y direction, we will press OK. And now we will go into our project name, which is a project for the fluid. We will right click and we will run to make the calculation. The calculation is gonna take a time. So we will pause this video until we got the result for the calculation. Here you can see before we pause, this is the area and this is the window for the calculation. It will take a time to finish. So now you can see the preparing for this model. After the pause, we have finished the calculation for the flow simulation. So now we will close this solver window, and then we can see the result is here. Here is the result. Before we start in the result, we need to hide the competition domain. So we will hide it. And now we will go to the result, into flow trajectories. We will right click and insert. There is a 3 types of points: pattern, pick from screen, and coordinates. So we will choose pick from screen. So now I will choose the area which is here, this circle. And now I will move this square in here. Now I will press space to select the face here. So now I can pick a point like this. I will insert many points in this circular area. This point is gonna to show the flow after we drop many points in this area. So we will go into the appearance. So traction, as we will change it from the pipes into lines. The line width is gonna be 1 millimeter only. So here is going to be many types. We can choose a pressure, temperature, velocity, or anything from this. But I will choose the velocity. Then I will press OK button from here. It will recalculate now. You can see the calculation for the velocity is here. So now you can see the result of the velocity flow. This is, here you can see the range from 0 until 43.523. So we can change this into 110. So now we can see. And now I will hide some of the plates here to show the result clear. Right click, hide components. Right click, hide this components. Right click, hide components. Right click, hide components. So now you can see the results from here. Also we can change from the velocity, we will left click. I will change it into pressure to show you the result. So here it's for the pressure. You can see it's the range of the pressure. This is not fully open. So we should to open by rotating like this. After we rotate this, we will go to the project. We will right click and we will press run to recalculate. Run. So now he's talking about the geometry of the model or project. First we will choose no, and the second one is the flow simulation has detected the model was modified. So we will press yes to change. So now we will wait for the calculation for a while. After finished of the second calculation, we need to close this window first, and we will go to see the new results for the calculation. So we will go to the flow trajectories, we will right click and we will press show. It will calculate again for the open. So now you can see that the difference between the fully open and not fully open. Here is the pressure flow, and we can change into the velocity to show you the difference. And that's for the velocity. You can see the flow for the both and the difference between the not open, not fully open and fully open. So thank you for watching my video. I hope you enjoy when you watch my video.